Any other alkene you can take. What kind of alcohol are we going to get? So if you take any other alkene, suppose ethene is the smallest one. If you take other alkenes, so if you are looking at these other alkenes, you will have either uh, secondary alcohol or tertiary alcohol. Got it? So what should be the right answer?
Sir,
This I hope is clear.
secondary and tertiary. Yeah.
Secondary and tertiary, right? Yeah. But why not primary? When we are going to get primary? Why primary and secondary is not the answer? So any other alkene means this could be propene, butene, right? So why that primary is not the answer? Now that is going to be generated by anti-Marconi competition. Okay. Primary, and this is acid catalyzed hydration. So that is Marconi competition. Got it? So that's why you will either have primary, you will either have a secondary or tertiary. Primary in the case of lithium. Got it? But if you go for higher alkenes, you will have carbon atoms. So secondary or tertiary alcohol, you are going to get. Okay. This is clear. This we discussed. The mechanism also we discussed, right? In the previous class. The rearrangement, can you tell me the answer? Final product. These type of questions are very common in NEET. NEET and JEE means both everywhere with rearrangement. This catalytic amount of acid H plus, right? H2O. This is acid catalyzed hydration of alkenes. Okay. Just you need to write the answer. But be careful about the rearrangement. That's what we discussed in the previous class also. So H plus is going to come over here, cation, and the cation will undergo rearrangement. Okay. So you will have this as a final. Got it? This is CH3 whole thrice here. One is ethyl. This one will become ethyl. Two CH3 and one ethyl. Got it?
Yes, sir.
Because this is secondary, so it will get shifted onto the left hand carbon and it will become tertiary. Got it? And then once it is stabilized, you will have this. Okay. This is one more process, oxymercuration, demercuration. Any idea what it is about? For the addition of alcohol. Making alcohol from alkenes, addition of water. But why do we need to have this method? What's the advantage? By adding water, not directly in the presence of dilute H2SO4, but with mercuric acetate. This is known as OMDM, right? So you have oxymercuration and demercuration. So with mercury, you are adding the water, mercuric acetate. In the presence of mercuric acetate, that acts as a catalyst, but it also prevents the rearrangement. Got it? Yeah, Ibrahim, welcome to the class. Am I audible?
Yes, sir.
So I was asking Jasleen that what is the advantage of taking mercuric acetate to add water? We have added, we did acid catalyzed hydration of alkenes, okay? That was with dilute H2SO4. We did hydroboration oxidation. That was anti-Markovnikov. What this oxymercuration demercuration is about? This is also addition of water, as you can see, but without rearrangement. Okay, Markovnikov is still Markovnikov, but without rearrangement. Rearrangement will not happen. So normal alkenes, it will just be the same. In this case, it is going to give you the different result. So if you take H plus H2O, as we have seen this as a previous question just now, we're going to have the cation. The cation will get shifted. You can see this rearrangement happening from secondary to tertiary. And then the wedge will form. But this is with rearrangement. Okay. And this method, mercuric acetate, is without rearrangement. But it is still Markovnikov. So you are going to, Ibrahim, Jasleen, are you getting my point or not? This is Markovnikov addition, but no rearrangement. Is it clear?
Yes, sir.
Yes, sir.
Okay, very, very important. Oxymercuration, demercuration. Look how it is happening. There is a, but no need to know the mechanism and all. Actually, the water is not getting attached directly, first the mercury is getting attached. And with the mercury, you have the attack of water taking place, and that cation, simple cation is not forming. So that because of that, the rearrangement is not happening. So this is the Markovnikov addition, oxymercuration, demercuration. Mercuric acetate you take, water you take in the first step. Then you take NaBH4 and NaOH. So that removes the mercury and put place H. So you have H and OH being attached. Okay, but without rearrangement. So let's do this problem. What should be the answer? The reagent I can write. The name is given. Jasleen Ibrahim, is the question clear to you? Any doubts in the question? Now you need to tell me the answer. Just add water in a Markunikov way, but don't carry out here. So what should be the right answer? Tell me quickly. Yeah, Jasleen, am I audible or not?
You're
Ibrahim.
audible, sir.
Yeah. So Markunikov addition, but you will not do the rearrangement. So Ibrahim H will go to the carbon atom bearing more hydrogens, right? And OH will get attached to the adjacent carbon adjacent to it. Okay. So that's what is Markovnikov addition. I hope it is clear to you. Got it?
Yes.
Yes.
But I have not done the rearrangement. Suppose if I have taken H plus H2O, then what would have happened? Then this cation would have shifted to next to benzene. Okay, because that is where it is more stable. Is that clear? So which reason do we need to get option C as the product of this reaction? Yeah, Jasleen Ibrahim, tell me quickly. I want option C as my answer. So what reagent do I need? That already we have covered. Yeah, Ibrahim, tell me. So we have seen total 3 methods. Jasleen, tell me which one do we need in this place? This is Markovnikov or anti-Markovnikov addition. Water is getting attached outside, okay, anti-Markovnikov. So what we are going to take over here? Tell me the reagent. Very simple reagent. That is also abbreviated as the name of a movie channel, Ibrahim. Yeah. Which one? BH3, THF, HPO. Got it?
Yes, sir.
This is so now can you compare the 3 methods? One is with rearrangement, one is without rearrangement, and one is anti-Markovnikov. Okay. This
Yes,
question. which we have seen. So let's do this. Propene to 1 propanol, OH outside. Got it? I hope this is clear. Right? This is the
Yes.
mechanism. You first start with the hydroboration. This is hydroboration part. And then you actually oxidize it, the boron towards. This is just you need to little bit remember it. Okay. So just do this question quickly. What is the right answer to this problem? Both the sides you are doing the same thing. Hydroboration you are doing and oxymercuration, demercuration you are doing. You are preparing alcohol in both the reactions. But the question is which alcohol? Getting my point or not?
Yeah, yeah.
So which alcohol, which should be the, what should be the right answer?
I think A will be Markovnikov. A is Markovnikov, yeah.
Yeah, A is Markovnikov. Yeah, but there is no rearrangement. Okay, the rearrangement stop with that mercury. Yeah, that is Markovnikov.
Mhm.
And this B is hydroboration, oxidation, HBO we discussed, that is antimark.
Yeah, okay, yeah. So it's B.
Yeah, B option is correct. So these questions are very, very common, okay, in all examinations, right? So we have gone through Grignard, right? As I told you, the basic idea, this you already know. Okay, but be careful, okay? So don't make any mistake in the question, right? Final, uh, just little bit care can fetch you good score, okay? So so this is the preparation of Grignard. So what are we to get? So what are we going to get? Jasmine, this is the preparation of Grignard, which we, the basics of which we have seen. This is MGBF. Suppose if you have the both Br and F side by side present in one molecule, just like this in this one. And when you react with Grignard, with whom do you form the Grignard? With the out of fluorine, chlorine, bromine, iodine. That's what matter in this question. Okay. So this is basically the Br bond is weaker, got it? And the fluorine is smaller, it is stronger. Clear? Ibrahim, just can you tell me why I made the Grignard with Br, not with F? What is
What's
the
it?
reason? Why I have chosen this, not this? What's the reason?
Maybe because, well, obviously fluorine can't bond magnesium, I think. So that's why.
Yeah, that is smaller. That is smaller halogen. That is stronger bond. Got it?
Yeah.
So if you are reacting with 1 mole of Grignard, go for the halide which can be broken more easily, right? I hope it is clear. Basic idea.
Yeah.
Okay, no? If one magnesium is given, be careful where do you need to form the grignard out of the two places? Okay, if iodine is given, then you would have chosen iodine, right? Why?
Because it's smaller
That
than
is-
Mg, yeah.
Yeah, that is larger and that is weaker bond. Okay, this is stronger bond, right?
Yes.
Oh, okay. So yeah, that's this we have seen today basic idea about the Grignard agent. This is the addition, nucleophilic addition that we have seen. I hope this is clear. Any doubts in this?
No.
Just saying Ibrahim. Yeah, this is, but you need to be very careful. Okay. This we have seen. Okay. In today's class, if you take CO2, then you will end up with carboxylic acid. This we have not seen because this is from the carboxylic acid chapter. Yeah, Jaslyn, which one? The previous slide or this slide? Yeah, okay. So previous one is also same. Suppose if you have taken a ketone and this grignard is there, this is minus and this is plus. Got it? So this R dash minus is going to come and get attached over here. Okay, and you will make this double bond or single bond. Put this R dash from the grignard. So this are you getting? And what will happen to this double bond O that will change to single bond because that pi electron is being pushed up. So that is minus and you have NDPR. When you react it with water, you will have OH. R or H, right? What happened to this one? It's the same. 2H were there. Ethyl is being connected to the carbon. This plane is it clear? Any doubts on this? But you have to be very careful while looking for the groups already present, right? And what you are bringing in with the help of Grignard, you have to be very careful. The same thing here also. Look, what all groups are initially present on the aldehyde or the ketone, and which group came in with the help of a Grignard. So the CH3 came in with the help of a Grignard. I have just highlighted it already. Okay. This question we did. Ibrahim, it's answered this question. Right, Ibrahim?
Yes, sir.
Okay. So this, but if you take CO2, you will end up with carboxylic acid. Okay. So let's do this problem. Very simple. linked to both the chapter, this as well as previous. Just one reaction, this or reaction also we discussed in today's class.
So A will be what? CH3, CH2I, yeah.
Yeah, CH3, CH2I, exactly. Good. Then you will make a Grignard out of it. Then you will be
And then
reacting it with
if we add,
formaldehyde. Okay, HCHO. Then what?
and then if we
So
react with
this,
Mg, we will
yeah,
get CH3, CH2, MgI, yeah.
yeah, CH3, CH2, MgI, correct. Then B2C. Then you react it with the formaldehyde. And you reacted it with methanol. Right? So this is also you are about to get the final answer in just one step more you need. Jasleen, Ibrahim, tell me quickly. Yeah, Ibrahim. Very close to the final answer. This is minus, okay. Attach this minus on C plus, make it single bond O. And with water it will change to OH. Got it? Ibrahim, are you getting this or not? Jasleen?
Yes, yes.
Okay, so
Yes,
this
sir.
is N problem. Okay, so this is entirely new question, but the concept we discussed in a very general way that you can apply the general concept, and this is partly from class 11th and partly from one concept which we discussed in today's class. But we have not exactly seen this compound, but concept we have already discussed. So try to figure out Grignard, who is minus, who is plus. That already we know. Once you have this minus and plus decided, whatever the reactant which is given to you, okay, look for the plus and minus in the reactant. So where do you think that plus and minus will be there, Ibrahim? Aisha is there. Jasleen, tell me. Where do you think? What will happen? What's this? You already have CH3 minus and MgH plus. Yeah, right. In the reactant, that triple bond, what is going to happen?
I think that the CH3 will join to one of the carbons, I think.
Yeah, this is H plus and minus. Yeah, am I audible, Ibrahim? And Jasleen is
Yeah.
facing some problem. Jasleen, you can check your connection, right? Or I will try to put my earpods. Yeah. Now I hope I'm audible. Yeah, that answer is correct, Jasleen. Right. So this is H plus. Okay. So this is CH3 minus. So ultimately you are going to get a methane. And the byproduct is this one. Ibrahim, can you make out this byproduct? MgX. Got it?
Yes, sir.
Okay. So this is new question, but the concept is saying that plus and minus you need to figure out, and you need to connect. This is and this terminal hydrogen of alkyne is acidic, and this is quite common question, but you need to be careful again. Only one correct option you need to choose. So this is the question from recent exams. A lot of exams are commonly giving such questions. Okay. You need to be very precise in writing the structure. Okay. Otherwise, if by mistake or you have written the wrong structure, the whole thing will go wrong, even if you know the concept. So this type of question, do you know it very well? I'm quite sure, but you need to be very careful while drawing the structures and while reading the names, occupation names. That is very important. So Jaslyn, now am I audible? Okay. So Ibrahim, what answer are you getting? Option A. Let's check whether, and Jaslyn, what option are you getting? A. Okay, let's check it. You have three hexane on this one. So instead of writing the complete structure, just write the skeleton. This is three hexanone, and you put methyl magnesium iodide. You put CH3, convert it to OH. Okay. So you are having this 3-methyl hexane all. Correct. Option A is the right answer. This we are going to discuss in aldehyde and ketones. Okay. So as of now, we can leave this. We can move on to that part. We would surely we will be covering in aldehyde and ketones. Okay. So this is, let's move on to the catalytic hydrogenation reaction or hydrogenation reaction or reduction reactions. Okay, reduction is actually a very important method to prepare alcohol, but reduction of whom? Reduction of aldehyde ketones. Okay, aldehydes and ketones already have double bond, and you need to put hydrogen atoms by reacting the aldehyde and ketone with H2 in the presence of catalyst. So this you can do it. Got it? I hope this is clear. Understood? This already we discussed. But in this case, we are having more different types of examples. The other reagents which we had seen are the
NaBH4 and LiLH4. So you can have different functional group present in the same molecule as we had seen. And you know that NaBH4 is mild reducing agent and it is going to react with the aldehyde and ketone only. This is clear, I hope. Any doubts in these reactions?
No, sir, no.
Okay. NH is strong, as I told you, and it is going to reduce aldehydes, ketones, but not only aldehyde, ketone, carboxylic acid, esters, okay, all the other remaining carboxylic acid derivatives. So you can see it happening in these reactions. So what is the answer to this problem? Reduction by LiLH4?
They're
Hydrolysis
looking for, I
product of
think,
an ester. Yeah,
an
that's
acid and
right.
an alcohol, yeah. I think
Hydrolyzed product will be acid. Suppose if you take the ester have two alkyl groups, and when you react them with water, it breaks, right? So carboxylic acid RCOOH and ROH. This is the hydrolysis product. Okay. And when you react this product with LAH, what you are going to get? You react this product with LiLH4. Reduction by LiLH4 of the hydrolyzed products of an ester, which are hydrolyzed products of an ester are carboxylic acid and alcohol. If you react them with LiLH4, what will happen? Hmm. So alcohol is already reduced, right, Jasleen? It's only the carboxylic acid which will reduce to alcohol. So what you are going to get after reduction with LAH? Initially you ended up with this, but read the question very carefully. After reduction with LAH, both were reduced to alcohol. I hope it is clear. Got it? Any doubts in this? So let's move on to the next one. This is the reduction by ester of ester by LiLH4. And we have already seen that NADH4 will not be able to do it. Okay. Is it clear or not? Ibrahim, is it clear? Justine?
Yes, sir.
So this ketone and aldehyde, you are going to get alcohol. But esters are two groups. Okay. So you are going to leave this bond and the two fragments both will become alcohol. That you need to remember. This question is a one new thing. I don't know whether you remember it or not. So just try to figure out what it is, then we will be doing it. So first try to figure out what is A. This is quite common, but you need to remember it. We discussed in the haloalkane and haloarine chapter. So what is the reaction with KCl? Tell me, Putra, whether you remember it or not. Yeah, Ibrahim, what is A? Jasmine, tell me. Yeah, Ibrahim. Yes, Jasmine, right. Ibrahim, what it is?
So it will be CH3Br, CN.
No, Br will
No,
come
wait,
out.
no. Yeah, CH3CN,
Yeah,
CH3CN.
CS3Cl. Correct. What will happen if you do the hydrolysis of Cl, nitride? Yeah, it will turn to break all the three bonds, put OH groups. Okay, that will turn to CS3COOH, carboxylic acid. Right, Ibrahim? Jasmine, correct. And then you treat it with LH, so this is going to get reduced to alcohol, PSP. So the end product C, no, not acetaldehyde. Acetaldehyde double bond, O, it will get reduced further to single bond O, because this is a strong reducing agent. It will not stop at aldehyde. Got it? It will get reduced completely there because a strong reducing agent, so it will reduce it to single bond OH. That is going to be the final answer. Is it clear? Acetaldehyde, there is a separate condition. Okay, but LH is a strong. Yeah, just Ibrahim, is it clear?
Yes.
So LH will not it will not react with carbon-carbon double bond because that is non-polar. Okay, there is no carbon, but it will completely reduce this double bond O, right? So this we have seen today, as you know it, reactivity is less. Okay, we have seen this in the previous chapter. Okay, um, alkyl halide and aryl halides, haloalkane, haloarine. How the OH attacks on the chlorobenzene and how the chlorine is replaced. Got it? Is that clear? This is from the previous chapter, but both are interlinked, so you need to be very careful. And once you have more nitro group, the reaction become more and more easy to take place. That what we had discussed in the previous chapter. Okay, and this is in previous chapter it was studied under the heading of chemical reactions of haloarenes. And in this case, it is the preparation of alcohol. This is sulfonation reaction. This is oleum. Either you can use SO3 or H2SO4 plus SO3 or H2S2O7. That is same oleum that we had discussed today. This is disonium, right? I hope this is clear. I'm just going through them quickly because you are already completed with this reaction. Okay. So this is cumene hydroperoxide. Let's do some questions. Okay, this is the question from the NEET. So let's try to figure it out. What is it should be and what should be the right answer. Hmm. Yeah, Jasleen Ibrahim, tell me this is quite easy and you should not take this much time. Tell me quickly. What should be the answer? Ibrahim, Jasleen, tell me. What is A? It is asking the structure of intermediate A in the following reaction is.
I think it will be A, yeah? Is it A? No, it isn't A, it's C. I think it's C.
Hmm?
I
Yeah,
think it's C.
yeah, cumene hydroperoxide. This is cumene and you will put OOH. Correct. Jasleen, is it clear? Option C. Okay, hydroperoxide. Hmm. This is also from NEET. Yeah, that one. This one. So actually this you react with oxygen and heat. What happens? This is cumene, isopropyl benzene. Right, you react it with oxygen. So oxygen react with that hydrogen. Okay, this one, this carbon, and the hydrogen attached to it. And oxygen oxidizes that carbon to hydroperoxide. So that's why this is the answer. So I hope Jasleen, is it clear to you? The C should be the answer.
Yes, sir.
Okay. This is more tricky, little bit more tricky. From the NEET itself. That previous question was also from NEET. So what should be the answer? This is alkylation. What is P? Yeah, Jasmine, maybe your connection problem. Just rejoin. Can you see the screen? Ibrahim,
So I think P will be the benzene with the CH2, CH2, CH3. That's P.
the normal propyl or isopropyl? That's the question. This one or this one?
It's normal, I think. It has to be normal.
Why normal?
Well, no, because it's aluminum, yeah? So
It is
pairs
given in
will
the question. Because of that, this group will get connected.
Yeah,
Or
yes, that's why. Yeah.
but there
CH3,
is,
CH2,
yeah,
CH3.
okay.
That's the
That is one thing. Okay. The another thing is that Cl will be removed. You have a cation.
Hmm.
Got it? And just now we are seeing in the previous class also, and today also in the first starting, that cation has always have a tendency to undergo rearrangement. Got it?
yes. The,
So it will get shifted to the middle. Always remember, there are many reactions in different chapters occurring through cation. So everywhere you are going to do the rearrangement. So P is either this one or this one. Okay. Is it clear or not?
oh, okay, okay. Yes.
Because of the rearrangement. Now this is quite clear. This you know already. This is that cumene hydroperoxide method. You so what should be Q and R? Yeah, Ibrahim. Jasleen. What should be Q and R? Either from C or D you are going to choose.
The Q will be normal phenol, yeah.
Yeah, Q is phenol and what is the byproduct?
Uh, 1 second. CH3. I think CH3, CHOH, CH3. I think.
No, that was acetone. Okay, not this one. Byproduct is that acetone. Is it clear or not?
Yes.
This link is it clear? So D is the answer. So remember, because we forget actually iso, and they have in this NEET question they have given the byproduct very cleverly. They have chosen the similar byproduct which look like acetone. Okay, isopropyl alcohol they have given, and acetone also they have given. Okay, sometimes we miss because we are bothered only about the phenol. So we miss that what's the byproduct. So this is the answer. I hope this is clear. Very important question. Okay. And this question, many students make mistake in this, right? I hope this is clear to you. Got it? So these are the physical properties. So let's discuss it on the next turn. But this question always one more thing. that in fieldcraft alkylation, always check for the rearrangement. That you need to look for. So that is very, very important. Okay, don't put the alkyl group as it is. Right, Ibrahim? Check for the rearrangements. Okay. Wherever you are having a ketone. So let's cover with the physical properties, acidic strength. Lot of things need to be covered in the next class. Okay, today we have gone through a lot of good questions of NEET and JEE. Okay. And these are the questions